Right. On the last part of this session, we'll discuss IBN, like I said, which is Cisco's version of network automation, basically, software-defined networking. Um, IBN builds on SDN, transforming a hardware-centric and manual approach to designing and operating networks to one that is software-centric and fully automated. So IBN, if I can put it this way, excuse me, it's a network management approach where you tell the network what you want. Intent. Intent, what do you want? You tell the network the objectives of your business, for example. Then the network does everything else. And from that definition, you can see the network is smart because you just tell it what you want, what you want to do, and it configures itself basically. Business objectives for the network are expressed as intent. IBN captures the business intent, uses analytics, machine learning, automation to align the network continuously, dynamically as business needs change. So in simple terms, IBN is a type of a network where you tell the network your objectives, the objective of your business, then the network uses analytics, machine learning, that is AI, to configure itself. Automation add to that. That is IBM basically. Right. I'm yet to see that in action. Hopefully we get exposed as much to IBM. All we know is manual configuration. Right. Cisco views IBM as having three essential functions: translation, activation, and assurance. So to make intent-based networking possible, we have those three. Number one, which is translation. And this is where the system captures the desired objectives or the business outcomes and translate them into policies. Right. So for example, you can tell network yako, could I want security for every user arikupinda network. And the network says that is a policy. It translates that objectives to a policy. Then that policy yozoendeswa to the physical infrastructure, which are our devices, our routers, our switches, and gets yoiswa ikoko as a policy with my devices, my access, my users, my are secure because that's the intent which has been translated from the client. Right. So translation in simple terms is translating the intent into policies. Then activation is where we apply the policies to the network. So you can see now in the network ish, physical infrastructure. All right. This is where we capture the objectives. Right. It gets translated into my policies. Then activation is applying my policies to the network. Everything is automated. Right. After activation, we have assurance. And this is where sort of feedback. I think this is the feedback. Continuous insight to management and perform corrective actions. So assurance is an ongoing process of verifying that the network is operating as intended. If it's not operating as intended, tozokapa intent, you translate as policies, gets activated, assurance. If it's not operating as intended, Then we have a cycle. Network, yoramba function yakadaro. So what helps? Everything that helps here with obviously automation. One, and I think most importantly, it's machine learning, ML, or AI. And that is the reason why, like I recently, if not yesterday, discovered there are new topics in the new version of CCNA, which includes machine learning and artificial intelligence. And I think one of those reasons is because of IBM. Right, I think that's a discussion for another day. So, three essential functions in an IBM network. In an IBM, translation, activation, and assurance. Typical exam questions, you need to know and define those three. Network infrastructure is a fabric. When we talk of a network fabric, this is basically the interconnection of the physical devices that we have and the virtual connections that we can have in a network. The physical devices, the physical infrastructure, the physical connections, the cabling, the logical connections, which are the virtual connections. Everything interconnected, that is what we call the network fabric. Right. In IBN or in software-defined networking, I think you learned of separating the physical hardware and the software. They're sort of separated. The data plane and the control plane, right? They are separated. It's the same concepts here, the same concept which is put across here. Here, however, we have what we call the overlay network. Okay, it's actually overlay control plane. Overlay network, which is sort of virtual. That is the virtual network. Example of virtual networks, virtual connections, for example. The ones you know, VPN, that's a virtual network. No physical connections, right? VPN, that's one. SDN, that's a virtual network, no physical connections, right? So the overlay network defines those virtual connections. And I think the whole concept is by separating the physical infrastructure and its physical connections with the overlay network, that is the virtual network. So starting with the network infrastructure as a fabric, that is the combination of those two. However, when you talk of IBN, SDN, they are being separated. Right. So the overlay, that is the visual. Then we have the underlay control plane, which are the physical devices that we have here. The underlay network is the physical network with the hardware responsible for simple forwarding tasks. The overlay network is being controlled by a controller somewhere. There's a controller which controls the overlay network, which controls the underlay network. Separation of the physical and the logical networks. Cisco DNA, Cisco Digital Network Architecture. Cisco implements the IBM fabric using Cisco DNA. The business intent is securely deployed into the network infrastructure, which is the fabric. DNA then continuously gathers data from a multitude of sources to provide a rich context of information. This information can be analyzed to make sure the network is performing securely and at its optimal level in accordance with the business intent and network policies. So in simple terms, the Cisco DNA is Cisco's approach to designing and implementing software-defined networks. So this is the SDN of Cisco. Like I said, for everyone else, they are called software-defined networks. Proprietary reasons, Cisco, they call it IBN. They started with IBN. And the architecture is called the Cisco DNA. So we can say in simple terms, the Cisco DNA equals the IBN, which is the intent-based networking, plus SDN, separation of the control and forwarding planes, plus a couple of analytics to not talk about ABN for assurance, obviously some security for the network. Not forgetting, if I can say, automation. So the Cisco DNA is a sum of all these things. Maybe some that I missed. No. Maybe IBN, SDN, analytics, security, automation. This is just Cisco's way of automating networks. Their architecture is called the Cisco DNA. Right? They have a couple solutions that they have. SD Access, SD-WAN, let me see. Cisco DNA Assurance, Cisco DNA Security. All right, starting with SD Access. SD Access basically is a solution from Cisco that focuses on securing and simplifying network access for users. It focuses on the users, the end users, and the end devices within a local area network. First intent-based enterprise network solution built using Cisco DNA uses single network fabric across a LAN and wireless LAN to create a consistent, highly secure user experience. So like I said, it focuses on the user. So SD Access focuses on the user. Then we have SD-WAN, which focuses on the wide area network. So if you have geographically spaced, for example, branches, you have branches in different areas. The solution that you need to automate your network is SD-WAN. For users in the local area network, we have SD Access. Then for wide area networks, we have SD-WAN. It simplifies and accelerates delivery of secure, flexible, and rich WAN services to connect data centers, branches, campuses, and co-location facilities. This one focuses on optimizing wide area networks, wide area network connectivities. Its key features obviously includes optimization, like I said, centralized management of the wide area network, security. Yes, security. So with wide area networks, obviously, we talk of firewalls, we talk of IPSs, intrusion prevention systems. So the solution offered by Cisco DNA called SD-WAN provides you with all that. Typical exam questions, you are given a description on the which solution is offered by DNA, which fits the description basically. So Kanaparotar was a more wide area network, is SD-WAN. Kanaparotar was my end users, is SD Access. Cisco DNA Assurance, this one used to troubleshoot and increase IT productivity, applies advanced analytics, provides real-time notification for network conditions that require attention. Machine learning continually. Cisco DNA Assurance, this one focuses on providing continuous visibility and insights into the network's health, right? Predict assurance network performance, right? Improve performance, network's health, real-time notification for network conditions. Okay, it focuses on the network's health, performance, security as well. Right. So if you want a solution which focuses on the health of your network, the solution that you will get from Cisco DNA is Cisco DNA Assurance. Basically, this is Cisco marketing via CCNA. The last solution, we have Cisco DNA Security, and I think that one speaks for itself. It focuses on providing security solutions within the DNA, the digital network architecture. And some of the benefits, that's for us to read theory-wise. So these are the 4 solutions that we have, which are offered by Cisco DNA. Cisco DNA encompasses network automation, so which is a sum of, like I said, intent-based networking, software-defined networking, security, automation, machine learning, everything within that. Then we have Cisco DNA Center. This is a foundational controller and analytics platform at the heart of Cisco DNA. It supports the expression of intent. It supports the expression of intent for multiple use cases, including basic automation capabilities, fabric provisioning, policy-based segmentation. Okay, long story short, the Cisco DNA Center is a platform. Voila, there it is. This is the platform. This is the Cisco DNA Center. Right? It's a platform that provides you access to these 5 main areas: design, policy, provision, assurance, and platform. If you have a network which is automated, so if you have IBN, automation, security via the Cisco DNA, you have a network that is automated. You need a platform to manage that network. In that platform, going on the Cisco DNA Center, and it allows you to design your networks. It allows you to create my policies, which are then used per party activation, to create my policies, which are then used to configure my devices. Provision, provide a new service to users with ease, speed, and security across your enterprise. Assurance, we've talked of this one. Then lastly, platform, use APIs to integrate with your preferred IT systems, create end-to-end solutions, and add support for multi-vendor devices. Long story short, this is the platform which, if you have Cisco DNA, you use to manage your network. And it has those 5 main areas. Without practice, it will be very difficult to explain some of these things. And I think this summarizes this last chapter of CCNA 3. I feel I have to, let me see, summarize again. Which one do I use? Right, this one. In summary, network automation that we've learned here, it has nothing to do with programming. No knowledge of programming required. Nada. What you need to know is definition. What is automation? It's this one. Right. What we need to know is, what is automation? Okay. Just a minute. Okay, let me just write on this one. All right. So you need definition of what is automation. automation. More specifically, what is network automation? You need to know that. You need to know why. Why you have network automation? How do we go from the traditional networks to networks that are automated? Why do we go? Before how, why do we go from the traditional networks to the ones that are automated? So we talked of uh, errors being made by engineers, humans, errors, typos. We talked of standardization. It's very difficult to maintain my standards with the different engineers uh, taking care of a network, administering a network, right? So that's the reason why we are moving to network automation. It's very difficult to scale configuring a huge network with a number of devices. That's why we have network automation. So why network automation? Clear. The benefits that come with that, obviously, right? Benefits. Yeah, but oh, you're going somewhere away. So benefits. PowerPoint yangu ya Mambara. Let me go through this one. Much easier. All right. Automation, definition. All right. Why automation? Benefits. Then formats, data formats. You need to know my data formats are. So we have JSON, we have YAML, we have XML. The difference between them, this one using my braces, my square brackets, my commas, my quotes. Right. This one, no quotes, everything above is not there. Then this one using is my tags. I think that's very easy. Data, tags, little bit of firefighting here. So if you see something with tags XML, if you see no quotes, no nothing, if you see quotes, brackets, that is JSON for you. Right, from here, you need to know what an API is. Definition, an interface which allows communication between different applications. And the format which is being used for that communication, DOMA data formats are represented YR3, an API. Then from my APIs, a sum of this DO foundation year automation, network automation to be more specific. So a sum of understanding my data formats are because that's the language, that's the format, text format which is being used to communicate or carry information, transmit information, store information. Knowing as well what an API can be used to retrieve information from a number of applications, communicate between different applications. That's the foundation of network automation. If you have a controller, if you have your API here, you can have your controller here. Controller communicates with the API. API communicates with multiple devices. So an API can communicate with this. Therefore, that becomes the foundation in automation. Instead of manually configuring a device one at a time, API makes multiple API calls. Fraction of time for basa rinogona a lot of time doing manually. Then from there, obviously, Cisco introduces IBN, which is by definition automation basically. IBN intent based. It uses translation, activation, and assurance. In simple terms, it has machine learning AI because you tell the network your intent, which are the objectives of the business, and the networks from that knows how to then configure itself. How it knows is through machine learning, programming. I hope there isn't much programming, but the new topics that was introduced. And with that said, Clark,